P-value approach. These are the steps in p-value approach. Step number 1, 2, 3 are same as in the critical region approach. From step number 4, one thing is changed, and that thing is what? After computing the value of test statistics, we have to look this value of test statistics into the table, probability table. And against that value of test statistics, we will obtain a probability. So here we have a probability against this value of test statistics. If this value of probability is called p-value, if this p-value is less than equal to alpha, we reject h naught. Otherwise, do not reject h naught. This is very important point, which we generally used in decision making. Very important point it is. How to take the decision if you have the p-value, as p-value is generally provided by the software if we are solving the problem in SPSS or in some other softwares. So we have a p-value and we have alpha, which is the level of significance. We have to compare just alpha and the p-value. If p-value is less than or equal to alpha, reject h naught, and our conclusion will be data provides sufficient evidence in favor of h1. If the p-value is greater than alpha, our decision will be data provides sufficient evidence in favor of h naught. So that is a very simple concept, and these steps are in continuation. Why these are in continuation? Because in critical region approach, we have a third step and four steps are not in continuity, because test statistics is computed, then the value of critical region is obtained by table. So these step 3 and 2 are not in continuity. Here we have a continuous step. Compute the value of Z statistics, search this value of statistics into the table, and determine a probability. That probability is called p-value. If p-value is less than alpha, reject h naught, otherwise accept h naught. Finally, step number 6 is same. Decision. The decision, as I told you, this statement is very important statement. We have to make the decision by this statement. If p-value, p is what? P is the p-value, alpha is what? Level of significance. You have to compare these two things. If p-value is less than equal to alpha, reject h naught. Otherwise, do not reject h naught. In this example, we have to obtain a p-value. The value of z score is given to us. Z statistics is given to us. Suppose we have computed in step number 3 the value of Z statistics, minus 1.19. And we have to left tail test and a p-value is to be obtained. So just look minus 1.19 into the Z table. Against that, we have a probability. This probability is this is p-value. This is minus 1.19. I located this number here, and this region, area of this region is the p-value. So at 5% level of significance, do the data provide sufficient evidence to reject the H naught? This is the acceptance or rejection criteria that we have to use, 5% level of significance. So in step number A, you have to determine the p-value. Very simple. Just search minus 1.19 into the table, Z table, because it is Z score, and obtain a probability from there. If we look the minus 1.19 into the Z table, to the value of probability is 0.1170. This is p-value. Region is left region. As you already know, that table will give us the region which is smaller than a specific number because it is a cumulative table. If we are looking this number, the p-value will be this. If we are looking this number, the p-value will be this, and so on. So that table provides us the left-hand area, not the right-hand area. Now for a decision, the p-value and the alpha, both we have. The alpha is 0.05, the p-value is 0.11, a p-value is greater than alpha. At 5% level of significance, data do not provide sufficient evidence to reject the null hypothesis. So our decision will be in support of hypothesis in favor of alternate hypothesis. Our decision will be what? Accept H naught. Our decision will be data provides sufficient evidence in favor of H naught, not in favor of H1. In this example, we have to compute a right-sided p-value. Previously, we were obtaining a left-sided p-value. Here we are obtaining a right-sided p-value. Z is given to us. It is 2.85. 2.85 is look up into the Z table and a probability is obtained. This probability is called p-value. So let's just look up 2.85 into the Z table and obtain this probability, and then take the decision at 1%. The probability 2.85, if we look up the 2.85, the area will be 0.9978. The 0.9978 is not this shaded region. 0.9978 is the region which is unshaded. So we have to obtain this because this is p-value. This is not the p-value. But table is giving us this region. But this region is not our objective. So we have 1 minus of 0.9978 and this is 0.0022. The 0.0022 is what? This is the p-value. Then you have to compare the p-value with the alpha. Your alpha is what? 1%, 0.01. So 0.01 is to be compared with 0.002. The p-value is less than alpha. Support will be what? 1% significance level data provides sufficient evidence to reject the null hypothesis in favor of the alternate hypothesis. In this example, we have to obtain the two-sided p-value. If you have to obtain a two-sided p-value against the z-score minus 1.71, this number will be used here. At 5% level of significance, you have to check whether the null hypothesis is true or not. The p-value is to be obtained. That p-value can be obtained by just looking minus 1.71 into the Z table. And directly we will have this number. Then we will double this probability because p-value comprised on this region as well as the probability of this region. So either we will double this number or we have to add these two times. The p-value against my 1.71, which is greater than, or minus 1.71, which is less than, the p-value is this 0.0436, and it will be doubled two times of this. This is not 2.0. This is 2 multiplied by 0.0436, and it is equal to 0.0872. This is the p-value. Then we have to compare 0.08, 0.05. The p-value is larger than alpha. P-value is larger than alpha. We do not reject the null hypothesis, accept the null hypothesis. Do not reject the null hypothesis, or in other words, we can say that we are accepting the null hypothesis. Now this is the same procedure T1, but this time we are using the step number 4, which is the right side of this slide. Step number 4, these are the p-values. To obtain the p-value and take the decision. So step number 4 in critical region, step number 4 was this, but in the p-value approach, step number 4. Those who are using the p-value do not consider the left side, consider the right side. Those who are using the critical region do not consider the right side, just consider the left side. This problem is again considered by p-value. Step number 1, 2, 3 are same. I am not repeating these 3 steps because it is already recorded. In step number 3, the value is computed as 2.85. This is called Z observed. Now 2.85 and our region is what? Less than, by, because we are assuming that increase, the alternate hypothesis have a greater than sign. So our p-value will be greater than this region. So that number is 2.85. 2.85 is looked into the table. 2.85, the p-value is there. The p-value is 0.0022. P-value is less than the specified rejection region, which is the Z alpha. Alpha is how much? In the problem, alpha is given as 1%, 0.01. The p-value is 0.002. P-value is smaller than alpha. Reject the null hypothesis and conclude that alternate hypothesis, the mean price has increased from the price of $78.01, which was the price in 2005. Similarly, we have the several more examples here by p-value and by critical region. As I told you, you have to complete these problems yourself because it is quite simple, and the same procedure is applied on 3 or 4 examples. The critical region and the p-value approach, two-sided, one-sided, left-sided, right-sided. That is why the 3 problems are discussed here. The next recording will be based on T statistics. This is procedure T2 that I will record.